Hey guys, so today we're going to be looking at how to multiply monomials. Before we talk about monomials and multiplying them, we need to know what is a monomial. So just breaking down the word here, when we look at it, we can see there are two base words. It's mono and nomials. Kind of an overlapping here. But the word mono means one. And then the second half of the word just means names or terms. So when we're talking about a monomial, we're talking about one term. And what we mean by term is just any number in this expression. Let's say I have an addition or subtraction of a bunch of different terms. These are individual terms here. And there can be anything in there so long as there isn't additions or subtractions in the middle of them. So for example, the number 3 could be a term. That's fine. The numbers 2 times x could be a term. That's totally fine. The number 9x squared y to the third divided by 5 could be a term. That would be fine, so long as there isn't additions or subtractions between the variables or the numbers. But if I had a situation like this, 2x plus y, this would not be a term because this is actually two terms. This would be a term, and then y would be a term, right? So we just need to make sure we understand what we're saying when we deal with terms. We're talking about numbers that are multiplied or divided together, such as 3, 2x, 9x squared y to the third divided by 5, or even on the smaller scale, 2x is a term and y is a term, but the entire thing, 2x plus y, is not a term. So just keep that in mind when we're talking about monomials. We're talking about things that are one term numbers. So here we have 3n times 6n. We may recognize here that 3n is in fact a monomial. And in fact, 6n is also a monomial. And so we're going to be multiplying these together. And let's just keep in mind this simple idea, which is called the commutative property of multiplication. And that says that if I have three numbers, like let's say 3 times 2 times 4, I could multiply those in any order I want, essentially, and get the same answer. So 3 times 2 times 4 is the same as 4 times 3 times 2, for example. You multiply all that out, you'll get 24, no matter what order you do it in. The idea here is we can reorder what we're multiplying in order for it to be convenient for us when we have variables. And let's go ahead and let's look at that. So instead of multiplying 3 by n, then 6 by n, I'm going to use my commutative property and say, well, I want to multiply 3 and 6 together first. And then I want to multiply my n's together first. N to the first power times n to the first power. And so 3 times 6 just gets me an answer of 18. And n times n, if you know what that is, that's n to the second power. And so our answer here, when we multiply these monomials together, is just 18 times n to the second power. All right, and let's look at this one. I notice I have two x terms here, x to the first power and x to the third power. So maybe I want to multiply x to the first power times x to the third power together, and then I can afford to leave this 7 out in front. And so I'm going to multiply it by 7 in the end. And then that boils down to 7 times. And x to the first power times x to the third power, you may remember this simple rule where I have some base to the mth power times some base to the nth power. What do I do with those? Well, I just add them so long as my base is the same. So since x is the base for both of these numbers, x to the first times x to the third is really just x to the 1 plus 3, which ultimately boils down to 7 times x to the fourth and that's going to be my answer. So these were a couple simple examples. Let's look at a little bit of a crazy one just to get the hang of this. All right, and there it is. So let's talk about that commutative property again. Remember, we can multiply it in any order I want to. So I'm going to take my plain old numbers that are defined, and I'm going to go ahead and multiply those together first. So it's 6 times 5. And then in green, maybe I'll take all of my x values. So I can see I have x to the third power times x to the second power times x as my x terms. And then I can take maybe some blue and do y to the negative first power times y to the second power. And when I simplify all this down, 6 times 5 is 30. X to the third to the second to the first. X to the third times x to the second times x to the first. If we add all those exponents together, since they're the same base, I get x to the sixth power. And then again with the y's, -1 plus 2, when I add all these together, is just going to be y to the first power. And so my final answer is 30 times x to the sixth times y to the first power.